Welcome to the second half of the video for section 8.1 and 8.2. Now that we've played around going between rational exponents and radicals, and we've done some things with radicals, we're going to talk about how to evaluate some radicals. We're going to deal with some examples. So consider this for a second. That symbol, again, is a square root. So we're asking what number squared is 121. To help, if you ever get stuck, the easiest thing you can do is you can just simply factor 121. So ask yourself what numbers go into 121. Go ahead and figure that out, and then unpause the video. Well, if you test numbers 1, 2, 3, well, 1 goes in, but 2, 3, 4, 5, 6, 7, 8, 9, and 10, none of those go into it, but 11 does. So in fact, I have 11 times 11. Thus, the square root of 11 is, square root of 11 times 11 is just 11, because I'm asking what number squared is 121. So 11 squared is 121, so the square root is 11. Now, you may ask, if you sit and think about it for a while, isn't 121 also equal to negative 11 times negative 11? So why was our answer just positive 11, not negative 11? Well, the reason being is that the square root of a number is always positive. So square root of a number is always positive. We're going to get into variables in a little bit later, and that's a different matter. But when it's just a number, all we're doing is we're going to get the positive. So to kind of illustrate this, I'm going to do this. Notice I have a negative on the outside. That's really like a negative 1 being multiplied by the square root of 49. So ask yourself, what kind of number goes into 49? Well, hopefully you're saying it's 7 times 7, which means that's going to come out as negative 7, but it's negative because of this negative in front, not because of anything that's going on inside. So it's all because of that negative that's outside. Well, let's do a fraction now. So what number goes into this? So what number squared is going to give me 9/10? Well, there's a really nice rule, and I'll explain this more in a later section. It's based on the whole exponent rules, but notice that I can break it up into the square root of the square root. So what's the square root of 9? So you're asking what number multiplied itself is 9, what number times itself is 100? Well, 9 is 3 times 3, and 100 is not 9, it's 10. So there's a typo, but you get the idea. Okay, what about this one? What's the square root of negative 81? If you think about it for a moment, there's no answer, because no number times itself is going to be a negative number. In fact, that's always the case. The square root of a negative number is always not real. It does exist. It gets in the whole imaginary number thing. That's where the letter I comes in. We're not going to do that in this class. In this class, if you saw something like this, you would simply say it's not real and move on. So we're not going to get into imaginary numbers. You would say it's not real and move on, because you cannot multiply a number together and get a negative number. Well, what about a cube root of negative 8? Well, we actually have done this one earlier. We just didn't think about it. Remember, negative 8 is equal to negative 2 times negative 2 times negative 2. It's because negative 2 is being multiplied together 3 times, and cube root's asking what number times itself 3 times. Well, that's obviously it's negative 2. And you can always work backwards by taking your answer and saying, if it's this to whatever power that is, does it equal what's inside? And it should. It really should. All right, what about this one? This is a 4th power. I want you to pause the video and see if you can figure out what is the 4th root of 81. Go ahead. Well, first off, one thing that helps is try factoring it. Well, 81 is equal to 3 times 27, which is 3 times 3 times 9, which is 3 times 3 times 3 times 3. Did I put an extra 3 in there? So 3 4 times. Because it's 3 being multiplied together 4 times, it is 3. That's it. Well, what about this example? What am I going to do if I have the fourth root of a negative number? Well, again, it's not real. And so what you learn here is if this number that's in here and that's tucked in here, if it's an even number, 2, 4, 6, 8, etc., then I can't have a negative number underneath. On the other hand, if this is an odd number, so 3, 5, etc., then if it's negative, it's always going to bring the negative outside. So that's just kind of a general rule. Keep that in mind as you work through this and use that to your advantage. All right, so now let's move on from radicals, that simplification. Let's talk about functions. So remember, a function is something like this, where I have something where I can plug in an x value and get it out. Well, I'm asking you to find the domain. So my first question for you is, what is a domain? Remember, domain, we're talking about the input values, or in other words, the x values of this. So because it's the x values, what x values are possible? I have a square root. What kind of numbers do I not want in my square root? Well, remember, we can't take the square root of a negative number. As a result of that, we want this, the thing that's underneath the square root, to be bigger than or equal to 0, because it can be 0, but we don't want it to be less than 0. It can't be a negative number. So because that's what I'm dealing with, let's just solve that. So add 2 to both sides, divide by 3, and I end up with my domain is x is greater than or equal to 2/3. What does that mean? It means I can have any x value that's bigger than or equal to 2/3. All right, so with that in mind, can you find the domain of this? Go ahead. Well, hopefully you start off by saying I have to have whatever's underneath the square root has to be larger than or equal to 0, like that. Well, if you didn't, pause the video and finish solving this. Otherwise, if you solved it, well, subtract 6 from both sides, divide by 5, and notice when I divide by -5, it's going to flip the inequality sign, so x is less than or equal to 6/5. If you want, you can always check by saying what's a number that's less than 6/5. Well, how about 0? I could take a 0 and plug it in and just ask if that value is there. All right, what about if I want to graph this now? How are you going to do that? Well, way back in the day, we graphed things by first finding the domain, because everything we had was a line, but let's find the domain because we want to know what x values we can even deal with. So I want you to pause the video and find the domain of that. Well, I have 2x plus 6 is what? It's bigger than or equal to 0. So I move that over. And x is bigger than or equal to -3. It's okay that it's bigger than or equal to a negative number. It's just the way it turns out in this particular case. So I'm allowed any x value that's bigger than or equal to -3. All right, now going back, I can let's make an xy table. And y, as a reminder, is what in terms of my function? Well, it's this. Remember, the value you get out is just whatever is here. So I'm going to pick some x values. I'm going to start with x is -3. So if x is -3, can you plug it into this function and find the y value? Go ahead. Well, as you did that, if you plug that in, and we multiply 2 times -3, and I get -6. -6 plus 6 is, well, 0, so I have the square root of 0. And the square root of 0, what number times itself is 0? Well, only 0. All right, so we have our first point. Now, I'm going to give you another x value, -1. Again, I want you to plug it in and find the y value that's associated with it. Go ahead. All right, if you do that, you get 2 times -1 plus 6, which is -2 plus 6, which is the square root of 4. 4 is a perfect square because 2 times 2 is 4, so it's 2. So your last one is I want you to use 5. Well, if you do 5, plug in 5 again, 10, 16. Square of 16 is 4. So now we have 3 points. I have -3, 0, -1, 2, 5, and 4. You could try more points. Now, before we go on, I'm just going to make a comment. Notice I seemingly randomly picked these. I didn't. I picked ones that I knew would come out as nice even numbers. Not everything when you take its square root is going to come out as an even number. For instance, if you put in x equals 0, 2 times 0 is 0, we've gotten the square root of 6. The square root of 6 is not a pretty number. It's actually an irrational number. It's impossible to write it as a fraction. So it's going to be a number that's going to be about 2.15, I think. And then it's going to keep going on forever. The decimal will never end. You'd have to estimate it. Well, for that very reason, we're not going to use it. I'd recommend if you try something and it doesn't work, try another x, and just keep plugging away. You should be able to get a few. Now, we're going to use these and we're going to finish graphing this because we now have our table. Now, can you plot all 3 of those points on the line? Well, hopefully you put them right there like so. There's our 3 points. Well, we have 3 points. Remember, our domain, though, is limited to be -3 and bigger, which means I can only have things on this direction. I can't have anything that's smaller than -3. So this point's the end of my function, and it's going to keep going in this direction. And normally we put an arrow on here, and this is what it looks. This is what the function looks like as it goes off in this direction. So this requires you to evaluate a square root to kind of see how it heads off in what direction. So this one's kind of nice. This problem's nice because it ties together. We'll talk about evaluating square roots and also finding domains. So it's all those things tied together. Well, let's move on to one last. We'll move on to the next section. As you move on to the next section, which we're going to talk about in 8.3, we're going to talk about how to multiply and divide all of these. And as you do so, please make sure you take the time. It's going to come back down to this. So please let me know what questions you have, and good luck with your homework.